Hello and welcome back. In this video we'll go over how we can move the more interactive version of the MNIST example into a Python file that we can, for example, use in a cluster. As we said previously, working with notebooks is very convenient if we do it interactively or if we work on exploratory data analysis and have a simple model. But it becomes more cumbersome if you want to develop real code or if you want to make use of efficient libraries and resources. In particular, this becomes important for deep learning, as if we don't have our own powerful GPU or GPU cluster available, we need to submit our code to a cluster, and this will best not run interactively, but we submit it when you don't. So that means that we need to convert our file into a Python file that runs standalone. So this is really the non-interactive version of the same example we had looked at previously, and the code essentially is the same. Let me quickly go over it. We have the same training loop as before with a few less comments, so it's a bit more compact. We have the same test loop as before. We define a simple network. Here we just use 3 fully connected flat layers, linear layers, with the input of 28 by 28 and the output of 10 for the 10 classes, and here the size of the MNIST data. We define the same network as we've done in our example. And the main difference is then that we define the main program, and remember that in Python, this is identified by the name. So if the name is main, then we do all the setups that we have done before. We get the training data, or we access it in folders if we have it, create the data loaders, get the device we can operate on, like GPU or CPU, initialize our model, define the loss function optimizer, and then run over these methods for training the network and testing its performance that we have done before. At the end, we save the model into this file, a .pt file, which is essentially the full model that we can then read in later. So if we have to find such a Python program, we can write, for example, a wrapper script around it, submit it to the cluster, and we will obtain the output.